Hello student, welcome to Learn More Maths. Today we are going to solve some previous problems from each chapter. Totally we have 14 chapters, 1 to 7 chapters are paper 1 and 8 to 14 chapters are paper 2. From probability what he asked previously, now we have to discuss. See student, we have 1 mark questions, 2 mark questions and 4 mark questions. Next objective type. Each type of questions now we have to discuss. First 1 mark questions what he asked from probability in the previously we have to discuss student. See here there is a problem from probability 1 mark question here. It is a March 2015 question. So what he asked, see here, when a die is rolled once, what is the probability of getting a multiple of 3 out of possible outcomes? So this he has asked student, when a die is rolled once, when a die is rolled once, see student, when a die is rolled once, when a die is rolled once, what is the probability of getting a multiple? What is the probability of getting a multiple? What is the probability of getting a multiple out of possible outcomes? A multiple of 3 out of possible outcomes, So this is previously asked for 1 mark question student. So when a die is rolled once, what is the probability of getting a multiple of 3 out of possible outcomes? So we have, if E is an event, then probability of EP of E is equal to favorable outcomes divided by total number of possible outcomes. This is the formula. So favorable outcomes of E divided by total number of possible outcomes. So student, when a die is rolled once, so total number of possible outcomes we have to write first. Total number of possible outcomes. Total number of possible outcomes. So what are the total number of possible outcomes? 6. So there is a chance to get to either 1 or 2 or 3 or 4 or 5 or 6. So these are the possible outcomes. 1, 2, 3, 4, 5, 6. So these are the total number of possible outcomes are 6. So now we have to find the favorable outcomes. Multiple of 3 he is asking. Multiple of 3. So from the total number of possible outcomes we have to select the multiples of 3. So multiples of 3 is equal to how many are there multiples of 3? 3 and 6. These are the multiples of 3. So multiples of 3 is equal to how many? 2. So they are 3 and 6. Therefore if E is an event, if capital E is an event, then P of E is equal to 2 by 6, that is 1 by 3. 2 by 6 is 1 by 3. This is a very easy student. When a die is rolled once, what is the probability of getting a multiple out of 3 possible outcomes? Multiple of 3 out of possible outcomes. First you have to write total number of possible outcomes are 6 and multiples of 3 is 3 and 6. There are 2. So if E is an event, then P of E is 2 by 6, that is 1 by 3. That's all. So one more student. The probability of an event is always in between 0 and y. 0 and 1. Why he is asking. So one more. The probability of an event. Second one. So the probability of an event. The probability of an event is always in between 0 and 1. In between 0 and 1. Why he is asking? Why it is always lies in between? the probability of an event always lies in between 0 and 1. Why he is asking, we have to say the reason. So generally we write if E is an event, then probability of E lies in between 0 and 1, and it is equal to 0 and it is equal to 1. So why he is asking? Because how can we define probability of an event? P of E. If E is an event, then probability of E is equal to favorable, number of favorable outcomes divided by number of favorable outcomes. Number of favorable outcomes divided by total number of possible outcomes. Total number of possible outcomes. Total number of possible outcomes. So this is the formula for probability of an event. So P of E is equal to number of favorable outcomes divided by total number of possible outcomes. So to find the probability of any event, first you have to write the total number of possible outcomes. Then after we have to select favorable outcomes from the possible outcomes. So always favorable outcomes are less than or equal to total number of possible outcomes. So if sometimes favorable outcomes will be equal to the total number of possible outcomes, in that case probability equal to 1. Sometimes favorable outcomes becomes 0, in that case probability becomes 0, and in all other cases favorable outcomes are always less than total number of possible outcomes. So hence probability lies in between 0 and 1. That you have to write, student. So what is the reason behind it? See, student, since always favorable outcomes are lies in between, favorable outcomes are less than or equal to total number of possible outcomes. Hence probability of any event lies in between 0 and 1. That you have to write. So next, student, see one more. Student, one more problem. Find the probability of getting a sum of the numbers on them is 7 when 2 dice are rolled at a time. So again it is also 1 mark. So see, student, what he is asking. Find the probability of getting, find the probability of getting a sum of the numbers, getting a sum of the numbers, a sum of the numbers on them is 7, when 2 dice are rolled at a time, when 2 dice are rolled at a time. So this he has given, student. Find the probability of getting a sum of the numbers on them is 7 when 2 dice are rolled at a time. So see here, when 2 dice are rolled, total number of possible outcomes. So first we have to write the total number of possible outcomes. When 2 dice are rolled, the total number of possible outcomes are 6 to the power 2, that is 6 into 6 is 36. So total number of possible outcomes, total number of possible outcomes, total number of possible outcomes equal to 6 to the power 2, that is 6 into 6, 36. So among this 36 we have to select the favorable outcomes when the sum of the numbers on them is 7. So favorable outcomes, So what are the possibilities for favorable outcomes, sir? So either first one is 1 and the second one is 6, 1 comma 6 and 6 comma 1 also. So by getting first on the first die 1 and the second die 6, 1 plus 6 is how much? 7. 6 plus 1 is also 7. So next 2 comma 5 and the same way 5 comma 2. So in the same way 3 comma 4 and 4 comma 3. So is there another possibility, any other possibility? So the sum of the two numbers must be equal to 7. So these are the possibilities to get the sum of the numbers on two dice is 7. 1 plus 6 is 7, 6 plus 1 is 7, 2 plus 5 and 5 plus 2, 3 plus 4 and 4 plus 3. Only these are the possibilities to get the sum of the numbers on the two dice is 7. So totally how many are there? 1, 2, 3, 4, 5, 6. So these are the set of possible outcomes. So total how many are there? 6. So therefore if E is an event, then probability of E is equal to 6 divided by 36, that is 1 by 6. You can cancel 6 ones and 6 are 36, that is 1 by 6. So to get the sum of the numbers on the sum of the numbers is 7, is probability is 1 by 6. So next one more student. Find the probability of getting a prime number when a card drawn at random from the numbered cards from 1 to 25. So it is also 1 mark he has given previously. So see student what he is asking. Find the probability of getting a prime number. Find the probability of getting a prime number. Find the probability of getting a prime number. Getting a prime number when a card drawn at random. When a card drawn at random. When a card drawn at random. When a card drawn at random from the numbered cards. From the numbered cards. From the numbered cards from 1 to 25. From 1 to 25. So see student, he is asked previously this. Find the probability of getting a prime number when a card drawn at random from the numbered cards 1 to 25. So there are some cards which are numbered from 1 to 25. If we draw a card from the total number of cards that are 25. If we draw a card, so then what is the probability that the card should be a prime number, he is asking. So first again we have to write the total number of possible outcomes. So how many cards are there student here? 25. Therefore total number of possible outcomes also 25. So that we have to write first. Solution, how can we write? Total number of possible outcomes. Total number of possible outcomes equal to total number of possible outcomes. So total number of possible outcomes here 25. So there are 25 cards here numbered from 1 to 25. Therefore total number of possible outcomes also 25. From the 25 cards, if we draw a card from the 25, then what is the probability to get the card prime number? So now we have to select. Now we have to write the all possible prime numbers from 1 to 25. So favorable outcomes, set of favorable outcomes equal to, first we have to write set of favorable outcomes. Set of favorable outcomes equal to So student, what are the favorable outcomes for prime numbers? What are the prime numbers from 1 to 25? So start from 2, 3, 5, 7, 11, 13, 17, 19, 23. So these are the prime numbers from 1 to 25. 2, 3, 5, 7, 11, 13, 17, 19 and 23. So how many are there count? 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are totally 9 primes between 1 and 9. So therefore P of E, if E is an event, P of E is equal to 9 by 25. 9 by 25. So that's all student. So next one more problem. So see student, again one more. From the first 50 natural numbers, find the probability of randomly selected number is a multiple of 3. So see here what he is asking. Again it is also 1 mark student. Today we are discussing only 1 mark questions from probability. So what he asked previously from the chapter probability, now we are discussing student. So from the first 50 natural numbers, 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 find the probability of, find the probability of, find the probability of randomly selected number, randomly selected number, randomly selected number is a multiple of 3. Selected number is a multiple of 3, is a multiple of 3, multiple of 3. So this he asked in the previous student. From the first 15 natural numbers, find the probability of randomly selected number is a multiple of 3. Again student, there are some numbers, natural numbers. Natural, what are the natural numbers? They starts from 1, 2, 3, 4 and so on. Okay, these are the natural numbers. Natural number starts from 1. 1, 2, 3, 4, 5. What are the first 50 natural numbers? 1, 2, 3, 4, 5, 6, 7 up to 50 are the first 50 natural numbers. From the first 50 natural numbers, if we select a number, then what is the probability that the number is a multiple of 3? So first we have to write again total number of possible outcomes. So what are the total number of possible outcomes? Here total number of possible outcomes equal to total number of possible outcomes. Total number of possible outcomes. How many student? Total number of possible outcomes equal to 50. What are they? 1, 2, 3, 4, 5, 6, 7 up to 50. These are the total number of possible outcomes. So now we have to write a set of favorable outcomes. Set of favorable outcomes. So set of favorable outcomes. So what are the favorable outcomes? They are multiples of 3. We have to select multiples of 3 from 1 to 50. So set of favorable outcomes, that is multiples of 3. So what are the multiples of 3? 3, 6, 9, 12, 15, 18, 21 and 24, 27, 30, 33, 36, 39, 42, 45, 48. So these are the multiples from 1 to multiples of 3. So these are the multiples of 3 from 1 to 50 natural numbers. So how many are there? Count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So directly we can write student 16 3s are 48. So there will be 16 multiples from 1 to 50. Directly you can write, but there will be a clarity if you write like this. So how many are there? Total number of favorable outcomes are 16. Therefore, if E is an event, then P of E is equal to 16 divided by 50. You can cancel by 2. 2 8s are 16. 2 25s are 50. 8 by 25 is the probability. So this is the answer, student, 8 by 25. So see, student, next one more. Next problem, see. So one more problem, student. A die is thrown once. Find the probability of getting a composite number. A die is thrown once. Find the probability of getting a composite number. So see, student, it is also one mark. A die is thrown once. A die is thrown once. A die is thrown once. Find the probability of getting a composite number. Find the probability. Find the probability of getting. Find the probability of getting. Find the probability of getting a composite number. Getting a composite number. So see, student, very easy. So how can we find the probability of getting a composite number? So a die is thrown once. Find the probability of getting a composite number. So again we have to write the total number of possible outcomes. If a die is rolled once, then the total number of possible outcomes equal to how many? 6. Here total number of possible outcomes. Total number of possible outcomes equal to 6. Total number of possible outcomes equal to 6. What are they, student? 1, 2, 3, 4, 5, 6. So these are the possible outcomes. So among these 6 numbers, you have to select the composite numbers. So they are the favorable outcomes. So what are the composite numbers among these 6? 4 and 6 are the composite numbers. So see, student, one is neither composite nor a prime. So 1 is neither composite nor a prime. 2, 3, 5s are the primes. Remaining are composites. So the numbers which can be written as, see here, 4 and 6, they have more than 2 factors. They have more than 2 factors are composite numbers. The numbers which have more than 2 factors are composite numbers. The numbers which have only 2 factors, 1 and itself, are called the prime numbers. So if you take 2, it can be written only 2 is equal to 1 into 2. So 3 is equal to 1 into 3. But if you take 4, 4 can be written as 4 equal to 1 into 4, and it can be written as 2 into 2 also. So it has totally 3 factors. In the same way, 6 also can be written as 6 is equal to 1 into 6. In the same way, 6 is equal to 2 into 3. It is also 4 factors. It has 1, 2, 3 and 6. So 4 and 6 are the composite numbers here. So total number of possible outcomes are 6. So favorable outcomes equal to only 2. Favorable outcomes equal to 2. So what are they? 4 and 6. Therefore, probability of, if E is an event, probability of E is equal to 2 by 6, that is 1 by 3. So probability of getting a composite number is 1 by 3. So if a die is thrown once, then the probability of getting a composite number is 1 by 3. So next, student, one more. So see student, one more. What is the probability of getting exactly 2 heads when 3 coins are tossed simultaneously? So important student, see here how can we do. So what is the probability of getting exactly 2 heads? What is the probability of what is the probability of getting exactly 2 heads, of getting exactly 2 heads, exactly 2 heads when 3 coins are tossed, when 3 coins are tossed, when 3 coins are tossed simultaneously. So see student, this is he asking what is the probability of getting exactly 2 heads when 3 coins are tossed simultaneously. So student, now we have to find the total number of possible outcomes when 3 coins are tossed simultaneously. So if 3 coins are tossed simultaneously, the total number of possible outcomes equal to total number of possible outcomes. Total number of possible outcomes, total number of possible outcomes equal to here 2 to the power 3. If 3 coins are tossed, total number of possible outcomes equal to 2 to the power 3, that is 2 into 2 into 2, how many? 8. So what are the 8 possible outcomes student? And now we have to write, see here, if 2 coins are tossed, the possible outcomes are, we know the possible outcomes. If both are heads, first one is head and second one is tail. So now here we have to write 2 times each one, head and head, head and head. So first one is head, tail, head, tail. So tail, head, again we have to write tail, head, tail, 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 tail. So see student, now we have to write head and tail, head, tail, head, tail, head, tail, head, tail. So these are the 8 possible outcomes. So when 3 coins are tossed simultaneously. So see student, how many? 1, 2, 3, 4, 5, 6, 7, 8. So among these we have to select exactly 2 heads. So where are the exactly 2 heads? Here there are 3 heads. It is not the favorable. So here there are exactly 2 heads. This is the favorable. Here also exactly 2 heads. This is also favorable. Here it is not favorable. This is favorable again. There are only 2 heads. Here it is not favorable. It is not favorable. It is also not favorable. So where there are 2 heads, we have to select it. Only there are 3 favorable outcomes. Favorable outcomes equal to how many student? 3. Favorable outcomes. Favorable outcomes equal to how many? 3. Then if E is an event, then P of E is equal to 3 by 8. 3 by 8. 3 by 8. So see student, with adding one word, the problem totally changes. What is the probability of getting exactly 2 heads? It is 3 by 8. If he asks like this, what is the probability of getting at least 2 heads? If you, instead of writing exactly, if you write at least 2 heads, then the answer becomes changes. So at least 2 heads means you have to take this is also. So 3 heads also you have to take, then it becomes 4 by 8. So while you have to read very carefully student, if it is exactly 2 heads, then it is 3 by 8. If he asks getting at least 2 heads, then it becomes 4 by 8. So it is also comes under at least 2 heads. So that you have to read very carefully. With only one word the answer changes. So one more student, so this is the probability of getting exactly 2 heads. Getting exactly 2 heads is 3 by 8. So next one more student, when a die is rolled, find the probability of getting an odd prime number. So very easy student, easy, directly we can write the answer. See student, when a die is rolled, when a die is rolled once, when a die is rolled once, what is the, find the probability of getting, find the probability of getting, find the probability of getting, find the probability of getting an odd prime number, odd prime number, odd prime number. See student, very easy. When a die is rolled once, find the probability of getting an odd prime number. So when a die is rolled once, then what are the total number of possible outcomes? Total number of possible outcomes are 6. So here we have to write first total number of possible outcomes. Total number of possible outcomes. Total number of possible outcomes equal to 6. Total number of possible outcomes equal to 6. What are they? 1, 2, 3, 4, 5, 6. So these are the total number of possible outcomes. Among these 6, we have to select the favorable outcomes for odd prime number. So favorable outcomes for odd prime numbers. First, you have to select what are the prime numbers? 2, 3, 5. These are the prime numbers. 3. These 3 are the prime numbers. Among these 3, we have to select only odd prime numbers. 2 is even prime number. 3 and 5 are the odd prime numbers. Therefore, favorable outcomes equal to only 2. Favorable outcomes equal to 3 and 5, 2. Therefore, probability of an event, if E is an event, probability of E is equal to 2 by 6, that is 1 by 3. 1 by 3 is the probability of getting an odd prime number. So, see student, one more. So next one more. From English alphabet, if a letter is chosen at random, then find the probability that the letter is a consonant. So very easy student, again from English alphabet, if a letter is chosen at random, from English alphabets, a letter is chosen, a letter is chosen at random, a letter is chosen at random, then find the probability, that the letter is a consonant, that the letter is a consonant. So see student, very easy. From the English alphabets, a letter is chosen at random, then find the probability that the letter is a consonant. So first student, you have to write the total number of possible outcomes. So total number of possible outcomes equal to total number of possible outcomes. So totally how many alphabets are there in English student? Total number of possible outcomes equal to 26. There are 26 alphabets in English. So A, B, C, D, E, F, G, H up to Z. There are 26. Among these 26, 5 are vowels and remaining are consonants. So 5 are vowels, remaining are consonants. So favorable outcomes equal to favorable outcomes. So consonants how many? Favorable outcomes. Consonants equal to 21. So among 26, 5 are vowels and 21 are consonants. Therefore favorable outcomes equal to 21. Therefore probability of E is equal to 21 divided by 26. Then what is the probability that the letter is a vowel? So then it becomes 5 by 26. So here he is asking the letter is a consonant. If he is asking find the probability that the letter is a consonant, that is 21 by 26. If he asks find the probability that the letter is a vowel, then it becomes 5 by 26. So that's all student. Next C student, one more. So that's all student. These are the 1 mark questions from probability chapter. He asked previously. These are the 1 mark questions from probability. So he is asking student, write to one more. There is one more student. Write 2 examples for equally likely events. Examples. 2 examples for equally likely events. Equally likely events. So he is asking to write 2 examples for equally likely events. What are the equally likely events? If a baby is born, if she is a girl or a boy. If a baby is born, then she is a boy or girl. Then there is a chance equally likely. When a coin is tossed, getting head or tail. So these 2 you can write. Example 1. If a coin is tossed, getting head or tail. So this is equally likely event student. It is equally likely event. If a baby is born, the baby is born boy or girl. If a baby is born, the baby is boy or girl. So these 2 are the equally likely events. These 2 are the examples for equally likely events. So that's our today's class student. In the next class, we will discuss about 2 marks questions. What he has to previously 2 marks questions from the chapter probability. So student, if you are watching newly, subscribe to my channel Learn More Maths by Vara Kumar. You can get latest updates.